Ever imagine teaching AI to recognize something it's never seen before?
Right.
Like you're building a self-driving car
Right.
and it needs to know that a giant spiky thing rolling down the road
Yeah.
is a tumbleweed to ignore,
Right.
not a person to swerve around.
Yeah.
That right there
Yeah.
is the challenge of out-of-distribution object detection.
Okay.
And that's our deep dive today.
Okay.
We're jumping into some cutting-edge research
Let's see.
on how foundation models like
Multiple.
Stable Diffusion, think of those as massive AI image generators,
Yeah.
could be the key to unlocking AI's ability to understand the unknown.
So what's fascinating here is how this research tackles a fundamental limitation of AI. So traditional AI excels at recognizing patterns within the data it's been trained on. But anything outside of that, anything it hasn't seen before, throws it off. And this isn't just about misidentifying a tumbleweed. In real-world scenarios,
Right.
a self-driving car misclassifying an object could have serious consequences.
Right.
Like you said, a confident mistake is still a mistake.
Exactly. And that's where these foundation models come in. It's like
Yeah.
giving AI access to a vast library of visual knowledge.
Exactly. These models, trained on enormous data sets, have internalized a sort of visual vocabulary of the world. Think of a large language model, for example. Even if it's never encountered the word scarecrow before, it can still generate a description of one based on its understanding of related concepts, like person, straw, and fields. Foundation models apply the same principle to images.
So it's almost like these models provide a shortcut to understanding the unknown. This is how AI might start to actually understand the world beyond its training data. But how do we actually put this into practice?
That's where SyncOOD comes in. This system uses foundation models to automatically generate what we call outliers, essentially never-before-seen objects, to train AI models.
So instead of relying on massive data sets of meticulously labeled images, we can use these foundation models to create the training data for us. That's fascinating because it opens up so many possibilities. Tell me more about how the SyncOOD system actually works.
It leverages a technique called image in painting to seamlessly swap existing objects in an image with these novel ones. Imagine taking a picture of a busy street and replacing a car with a tractor, or maybe even a snowmobile, all while maintaining a realistic-looking scene.
This is interesting. So we're creating these weird images. But it sounds like there's a method to this madness, right? What's the advantage of training AI on these bizarre but believable images, as opposed to just, say, pasting a picture of Bigfoot onto a stock photo background?
You've hit on a crucial point. It's about more than just seeing the outlier. It's about context. The researchers found that even subtle changes in the background of an image can influence an AI's ability to identify the outlier object correctly. It's like the AI picks up on the overall weirdness of the image, not just the object itself.
That's wild. So if you put a perfectly normal-looking penguin in the middle of Times Square, the AI might not even register it because the context is so off. That actually reminds me of that time I saw a guy walking a llama down Fifth Avenue. Totally normal object.
Yeah.
Completely bizarre context. But what does this tell us about how AI learns?
It highlights the importance of context consistency in training data. The AI needs to learn to separate the novel object from its surroundings and focus on its unique visual characteristics. And that's where SyncOOD gets even more impressive. It doesn't just generate these weird and wonderful images. It goes a step further by using a technique called SAM, the Segment Anything model.
Okay. Yep, you can break that one down for me. What's SAM and what's so special about it?
Imagine you're trying to teach a child to identify a cat. You wouldn't just show them a picture of a cat surrounded by other objects and say, see, that's a cat. You'd probably point to the cat, trace its outline, and highlight its distinctive features.
Right. You'd want to make sure they weren't distracted by the dog in the background or the furniture. You want them to really focus on what makes that furry creature a cat and not something else.
Exactly. And that's essentially what SAM allows SyncOOD to do. It creates precise boundaries, what we call bounding boxes, around these novel objects. It's like giving the AI a high-powered magnifying glass to zero in on the outlier's key features.
So it's not enough to just tell the AI, hey, something's different here. We have to show it exactly what makes that thing different. That's really interesting. Because that makes me think about how we teach AI in general. It's like we often focus on teaching AI to recognize patterns. But this research is about teaching it to recognize the absence of patterns, the things that make something unique or unexpected.
That's a really insightful observation, and it gets to the heart of why this research is so significant. It's about pushing AI beyond simply classifying what it already knows and towards a more nuanced understanding of the world. This has huge implications for the future of AI. Think about it. AI systems that are less prone to errors, less reliant on massive labeled datasets, and more capable of navigating the unknowns of the real world.
Wow, that's a future I can definitely get behind. Self-driving cars that don't freak out over tumbleweeds.
Hmm.
Security systems that can spot genuinely unusual activity. The possibilities are pretty much endless.
Exactly. But it's not just about making AI more capable, it's about making it more trustworthy. If we can teach AI to be more aware of what it doesn't know, we can build systems that are more reliable and less likely to make critical mistakes when faced with the unexpected.
That makes a lot of sense. But this all sounds incredibly complex.
Right.
What does it actually mean for the average person? What's the key takeaway here?
This research gives us a glimpse into a future where AI can constantly adapt and learn from new information. It's a step toward building AI systems that are not only smarter, but also safer and more collaborative.
So we're not just talking about a future of smarter AI. We're talking about a future of safer and more collaborative AI. That's a pretty exciting thought to end on. But before we wrap up, is there anything else from this research that you think our listeners should know about? This whole conversation about foundation models and their ability to kind of imagine the unknown has really got me thinking.
Yeah, what's caught your attention?
Well, we've talked about the benefits,
Oh.
AI that's more adaptable, trustworthy, all that good stuff. But if AI can imagine things it's never seen before, doesn't that also come with some inherent risks?
That's a very astute observation, and it's something that researchers are grappling with right now. While this ability to extrapolate and imagine has incredible potential, it also means AI could theoretically conceive of things we haven't even considered. Things that could be beneficial, absolutely, but also things that might be unexpected or even undesirable.
So it's like we're opening Pandora's box a little bit. We're giving AI the tools to think outside the box, which is amazing.
Yeah.
But we also have to figure out how to make sure it doesn't go too far outside the box, right?
Precisely. It's a double-edged sword. On one hand, this kind of AI could lead to breakthroughs in all sorts of fields. Imagine AI assisting in medical discoveries, helping develop innovative new materials, all because it can explore possibilities we might never have imagined on our own.
But on the other hand, we need to think carefully about how we guide that exploration. How do we set boundaries? How do we make sure that AI's imagination ultimately aligns with human values? It's a fascinating challenge, for sure.
It is, and it goes beyond just the technical aspects. This research isn't just a technological leap, it's a philosophical challenge. It forces us to confront fundamental questions about the nature of intelligence, creativity, and even consciousness.
Well, that took a turn. I think we need a whole other deep dive just to unpack all of that. But for now, I think that's a perfect place to leave our listeners with something to ponder as they go about their day.
Indeed. This research is a powerful reminder that the most profound advancements in AI aren't just about making machines smarter, they're about expanding our own understanding of what's possible, and perhaps even what it means to be human in a world where AI can increasingly imagine the unknown.
So until next time, keep exploring, keep questioning, and keep diving deep into the fascinating world around us.